Okay, Muniba, so let's not wait for them. So let's just start the session. If they join in between, then it's okay. So the next topic is the reduction of your aldehydes and ketones. So how the aldehydes and ketones can be reduced. So we have already done this topic. I think like of aldehydes, reduction of aldehydes to alcohols. You can this reaction is very simple. Suppose this is your carbonyl compound. Okay, it can be either your aldehyde or ketone. If you use different reagent, right? Suppose not reagent, you can tell me that it's a reducing agent. Suppose we just use the lithium aluminum hydride. Okay, so it's a good, strongest reducing agent, right? And you can also use a sodium borohydride. Okay, and you can also do the catalytic hydrogenation. In all the three cases, okay, if you use a lithium aluminum hydride, so it's a strong reducing agent, it can reduce any of the group. Okay, so it will reduce this carbonyl group to the corresponding alcohol. So what you're supposed to do, just break this bond and add OH group over here. And this will be as it is. 1, 2, 3 bond, and here you will add one hydrogen, right? So it will be reduced. So you have to basically, what is reduction? The addition of hydrogen, right? So what you're supposed to do, just break this double bond. Okay, the pi bond will be break down, and you will add one hydrogen over here. Okay, just add it to the oxygen side, and one hydrogen you will give it to the carbon. Okay, so that's a reduction. So this carbonyl compound, it will be reduced to the corresponding alcohol in the presence of any of the reagent. Okay, any of the reducing is strongest we have used conceptually, we can use the sodium borohydride. Okay, this sodium borohydride is especially for the reduction of this carbonyl group to the alcohol. And you can also do the catalytic hydrogenation. Okay, hydrogenation in the presence of a catalyst. Okay, now can you tell me, Muniba, if you reduce the aldehyde, so it will reduce to which alcohol, primary, secondary, or tertiary?
Primary.
Yes, primary. Suppose we have your CH3, right? CHO group. Okay. So if you use the suppose sodium borohydride, NaBH4. So what I said, you have to break this bond. Okay, one hydrogen, just give it to this oxygen, and one hydrogen to this one. So it will form CH3. Okay, and to this carbon, two hydrogen, CH3, CH2, and this is OH. Right. So you can say that if you reduce the aldehyde, okay, this is aldehyde, so it will reduce to corresponding primary alcohol. Now, if you take ketones such as acetone, if you take CH3CO, CH3, okay, and if you treat it with sodium borohydride, okay, again the same thing you will do, just break this pi bond, one hydrogen add to the oxygen and one hydrogen to the carbon. So what it will give you? It will give you CH3, CH, CH3, and here OH. So when you reduce the ketones, so ketones will get reduced to the secondary alcohol, right? And the aldehyde will get reduced to the primary alcohol. Okay, Muniba.
Yes, ma'am.
Next is second reaction in the reduction is reduction of carbonyl compounds to alkanes. To alkanes. Okay, so in this, we will discuss two types of reaction, Clemmensen reduction reaction and Wolff-Kishner reaction, and both are equally important. All the name reaction in your syllabus are equally important. They can ask in your boards any reaction. They will give you the name, what is Clemmensen reduction? What is the which reaction? Write down the reaction involved in the Clemmensen reduction. Write down the mechanism, etc. So they can ask you this type of question, direct question they can ask you by the name reaction. So reduction of carbonyl compounds to the alkanes. So if you take the carbonyl compound, okay, so it will get reduced to CH. So again, you will do the same thing, right? Not the same thing. Basically, you have to remove this oxygen. आपको oxygen remove कराना है and you just add the H2, two hydrogen to this carbon. So it will form a alkane. Will form alkane. So in this, We will discuss two types of reaction. A is your Clemmensen reduction. Clemmensen reduction. Okay, so what is Clemmensen reduction? So Clemmensen reduction is a reduction reaction, okay, in which the carbonyl compounds get reduced to the corresponding alkane plus water. Okay, the dehydration will occur, okay, and you will get the carbonyl compound will get converted into alkane in the presence of zinc amalgam. In the presence of zinc amalgam. So just remember that. Clemmensen reduction में आप क्या use करते हो? The carbonyl compound, okay, it will get reduced in the presence of Zn plus Hg. Zn plus Hg, this combination is known as zinc amalgam. Okay, in the presence of acidic medium. Yeah. The difference between the Clemmensen reduction and the Wolff-Kishner is that Clemmensen reduction occurs in a acidic condition, but your Wolff-Kishner occurs in a the reduction occurs in a basic medium. That is the difference between these two, Clemmensen reduction and the Wolff-Kishner. In both the reduction reaction, you will get the same product. You will get the same product. Basically, carbonyl compound is getting converted into a alkane. Okay, but the reagent you will use different and the medium will be different. Clemmensen reduction में क्या होगा? Acidic condition. Okay, it will occur in acidic condition. Okay, acidic condition. Right, but the Wolff-Kishner reduction, which we will see further after this Clemmensen reduction, it will occur in the basic medium, okay, alkaline medium. So here in the Clemmensen reduction, when the carbonyl compound is treated with the zinc amalgam, okay, Zn plus Hg in the presence of acidic medium, HCl. So what happens? The reduction will occur. What you're supposed to do, just oxygen remove kara do, this double bond oxygen, okay, and add 2 hydrogen plus water. Okay, so that is your Clemmensen reduction. Clemmensen reduction. Suppose, let's take some examples. First, CH3, CH2. Okay, now you will write down the product. If you use zinc plus Hg, the presence of acidic medium. So what will be the product? Second, if you use ketone, same reagent, zinc plus Hg in the presence of acidic condition. Third, let's take a aromatic system. Suppose let's take a benzaldehyde. Okay, when you reduce this using the same reagent, so what will be the product? Write all the products.
And the first one is ethane.
Okay, it's ethane. So basically, the oxygen will get the oxygen you will remove and you will add 2 hydrogen to it. So it will become CH3 and CH3. Right? So ethane. Now the next one, Maniva.
Propane.
1, 2, 3. Yeah, it's propane. Next,
Benzene with methyl.
what we call this group? Benzene will methyl ring. Benzene ring with methyl group. What is the common name? Yes, benzene ring with the methyl group. What we call this?
Toluene.
Yes, it's toluene. Okay. So is it clear this reaction?
Yes, ma'am.
Okay, now see the next reaction. It's Wolff-Kishner reaction. Okay, so it is again the reduction reaction, right, in which the carbonyl group will be converted into a alkane. Okay, but here we will use the different reagent, okay, and it occurs in a basic medium. That's the difference between the Clemmensen and Wolff-Kishner. Basic medium में होता है ये. Hmm. Now, so let's see the reaction. This is your carbonyl group, okay, and here you will use the hydrazine. Okay, when the carbonyl group is treated with the hydrazine, so it will give you a corresponding imine, hydrazone basically, it will give you a hydrazone. And after further in the basic condition, you will achieve the alkene. Now tell me, Muniba, what is the hydrazine? What is the formula for hydrazine?
NH2, NH2.
Yes, NH2, NH2. Now you know the mechanism very well. When the carbonyl compound is there, we have already discussed this is a carbonyl compound, and you are just treating it with the ammonia derivative. What is this? This is ammonia derivative, right? So we have already done this. Okay. Now just write down the mechanism, Muniba. Just write down the product. Carbonyl compound when treated with the hydrazine. So what will be the product? We have already discussed in the previous class.
C double bond N NH2.
Very good. So what is the name? What is the common name of this one?
Hydrazone.
Hydrazone. Yes, this is hydrazone. Now we have just add the any your suppose KOH. Okay, so this reaction, Wolff-Kishner reduction, occurs in a basic condition. So when you add KOH, so what, and you will give the heat. So this hydrazine, basically this N2, it's a good living group, right? So it's a good living group. So it just left, and you will get a corresponding alkane. Okay, so that is the Wolff-Kishner reduction. The reduction process, okay, when the carbonyl group is converted to a corresponding alkane in the presence of hydrazine in basic medium. Okay, just learn the difference between these two. Clemmensen reduction occurs in an acidic condition, right? So again here, the carbonyl compounds get converted into a alkane, okay, in the acidic condition. But in Wolff-Kishner reduction, the carbonyl compound gets reduced to a corresponding alkane in the presence of a hydrazine, okay, with basic condition, in a basic condition. Okay, just learn the difference between these. So these are important for your exam. Okay, Maniba?
Yes, ma'am.
Okay, just quickly write it down.
Done, ma'am.
Next, write down the electrophilic aromatic substitution. Electrophilic aromatic substitution of your carbonyl compound. Okay, now aldehydes and ketones जो होते हैं, they are deactivating groups, right? They are deactivating groups. Can you tell me why they are deactivating groups, Maniba? Why aldehydes and ketones are deactivating groups? Hmm? Due to the presence of minus M effect. Okay, I've already explained this in details when we were doing the alcohol chapter. So write down aldehydes and ketones are deactivating groups. Why? Due to the minus M effect. Minus M effect. Okay, so due to the presence of minus M group, okay, so it shows the minus M effect, and in the when the group show the minus M effect, you know very well, only meta product will be formed. Only meta product will be formed. So in the electrophilic aromatic substitution reaction, they will form only meta product. Just remember that. Meta product. Suppose, let's take example. Suppose we just take the benzaldehyde. When we do the chlorination, okay, so when we add Cl2 plus FeCl, Cl2 plus FeCl3. Now tell me, Moniba, in this reaction, what is the electrophile? What is the electrophile and what will be the product here? Because in this type of reaction, in nucleophilic substitution reaction, electrophilic substitution reaction, you should know which group is electrophile and which group is nucleophile. Okay, so that you can write on the right product. No?
Can you repeat the question?
Yes, I asked you, in this reaction, when the benzaldehyde is treated with Cl2 plus FaCl3. So basically, we are just doing the chlorination. So in the chlorination of benzaldehyde, which group is electrophile here?
FeCl3.
FaCl3? No, we are just doing the chlorination. So Cl plus will be the electrophile here, right? So you will attach the chlorine on the meta position, right? Okay, so it will form metachlorobenzaldehyde. So electrophilic aromatic substitution of benzaldehyde, okay, or you can say aldehydes and ketone will give you a meta product. So you have to analyze which group is electrophile here and just attach that electrophile on the meta position. You will get the product. That's very simple, right? So what is the name of this compound? So this is a meta. Okay, on the meta position, chlorine is attached. So it's meta chloro, and what is this? This is your benzaldehyde. So metachloro benzaldehyde is your product. Okay. Now let's do the another electrophilic substitution. So suppose if you do the nitration. So nitration may we use which group? Concentrated H2SO4. Okay, concentrated H2SO4 plus concentrated HNO3. HNO3, right? So when you do the nitration, so what happens here? What is electrophile in this reaction, Maniba?
HNO3.
HNO3. HNO3 will H plus and NO3 minus, right? NO2 minus. So basically, concentrated, when you do the nitration, just remember that when you are just doing the nitration of any compound, so the here electrophile will be NO2 plus. So basically, you have to attach the NO2 plus on the meta position. This is your benzaldehyde, right? Just attach this electrophile NO2 on the meta position. So what is the name of this compound, Maniba?
Metanitrobenzaldehyde.
Yes, good. Meta nitrobenzaldehyde. Next, if I do the sulfonation, okay? So sulfonation may we use concentrated H2SO4. Okay, only when the benzaldehyde is treated with concentrated H2SO4, right? So this process is known as sulfonation. Right. So here, what is the electrophile? So electrophile in this case is SO3H plus. Okay, just attach this electrophile on the meta position. This is benzaldehyde, and just attach this SO3H on the meta position. So what is the name of this compound? Meta. Okay, just try to name this. Yes, Moniva, just try to name this.
Um,
No?
is it formyl benzene sulfonic acid?
Yes. Okay, so we can also write metaformyl benzene sulfonic acid. Or you can directly call it as metabenzaldehyde sulfonic acid, right? So these are the electrophilic aromatic substitution of your benzaldehyde. Okay, so we have already discussed the aldehyde topic. Now let's take the example of ketone. Okay, aromatic ketone. So suppose we just take the acetophenone. Just take the acetophenone. Okay, so what is this? This is your acetophenone. Just do the same thing. First chlorination karo. Do the chlorination FeCl3. Now you will write down the product in all the cases. Now you know the electrophile in all the cases. Just attach the electrophile on the meta position. Okay, and just try to write on the name. Yes, done, Muniba.
Yes, ma'am.
Okay, tell me the first answer.
First one is metachloroacetophenone.
Very good. So you will attach the chlorine group on the meta position. So you will get this structure. Metachloroacetophenone. What is the second one?
Metanitroacetophenone.
You will get meta nitroacetophenone. Okay, what is the third one?
Meta-acetyl benzene sulfonic acid.
Yes. Okay, so basically this group is known as acid group. Okay, acetyl group, COCH3. And on the meta position, SO3H is there. So you will write meta acetyl benzene. What is this? This is your acetyl benzene. Okay, and this is your sulfonic acid. Benzene, sulfonic acid. Okay, so that's all about the electrophilic aromatic substitution. Okay, is there any doubt, Muniba, from this topic?
No, ma'am.
Okay, so let's see the next two topic, which is oxidation of aldehydes and ketone. Oxidation of aldehydes and ketones. Okay, now see, because aldehydes have a alpha hydrogen, right? Aldehydes have a, this, suppose this is a CH3, COH. So aldehydic group have a alpha hydrogen, so it can easily get oxidized to carboxylic acid. Okay, but your ketone does not oxidize easily. So oxidation of ketone is not very easy. Okay, only possible, it is only possible in extreme condition, in when you are just giving the strong oxidizing agent. So the oxidation of ketone is possible. Why it is not possible? Because ketones lack ketones lack alpha hydrogen, right? This ketone, this oxygen is attached to this carbon, right? But this carbon has no hydrogen. So due to that, ketones lack a alpha hydrogen. Okay, a hydrogen atom is lacked on the carbonyl compound, carbonyl carbon. So here in the ketone, if you are using the mild oxidizing agent, so ketones key do not react with the mild oxidizing agent. Just like your tolerance reagent or Felling's reagent, when we use the Felling's solution or tolerance reagent, so the oxidation of ketones does not take place. Okay, so that's why ketone does not give the tolerance test. Okay, why? Because they, see, we will discuss it in details. Let's first write down some topic. But there are some reactions, some oxidation reaction, just like your Baeyer-Villiger oxidation reaction, in which you will use some in some extreme conditions, like Baeyer-Villiger oxidation reaction जो होता है, this Baeyer-Villiger oxidation reaction, right? So here, this reaction uses basically a peroxycarboxylic acid. So in this peroxycarboxylic acid आप जब use करते हो, so this ketone will convert into a ester. Right, so this is highly a specific reaction, which is basically it can be controlled to achieve a desired product. So for achieving the desired product, we can use this type of oxidation reaction. So Baeyer-Villiger oxidation reaction is again very important. Okay, this name reaction is very important, and in this reaction, we can convert the ketone also. We can oxidize the ketone into a corresponding ester. Okay, in the presence of peroxycarboxylic acid. So what is peroxycarboxylic acid? RCO3H. So in the presence of this peroxycarboxylic acid, we can oxidize the ketone to a corresponding ester. But normally oxidation of ketone is not very easy because of lack of alpha hydrogen. Okay, now you can write it down. First, write down aldehydes easily get oxidized to carboxylic acid, but ketones does not. Ketones don't. Okay, so oxidation of ketone is possible only in the extreme condition. Next point, write down. Since oxidation of aldehyde is easy, it's easy, so it can be oxidized via a mild oxidizing agent. So you can also use the mild oxidizing agent to oxidize the aldehyde to a corresponding carboxylic acid. So it can okay, now let's suppose if you take RCHO group, aldehyde group, okay, and if you add like silver ammonical nitrate, okay, if you use this complex silver ammonical nitrate, AgNH3 whole thrice NO3. So what is this? This is silver ammonical nitrate. So it will give you Ag plus ion. Okay, and due to the presence of this, so it reduces the Ag plus. This is Ag plus, okay, and it will basically reduce, and you know very well what is oxidation and oxidizing agent. So where here you are using the oxidizing agent, this. Oxidizing agent is those agent which oxidizes others, but itself it get reduced, right? So Ag plus itself, it will get reduced to Ag plus to Ag. Okay, so what is reduction according to you, Monica? What is reduction? The gain of electron or loss of electron? The gain of electron or loss of electron? Hmm? Yes, Jupiter?
Loss of electron.
Are you sure? I'm asking for the reduction.
Okay. Gain of electron.
Obviously, loss आपने बोला loss नहीं होगा तो gain नहीं होगा, right? See, what is oxidation? That's the basic thing you should know. Oxidation, and here I'm writing the reduction. So this is a class 9th topic, 8th, 9th में आप पढ़ते हो. So oxidation is the loss of electron, right? And the what is reduction? Reduction is the gain of electron. Gain of electron is reduction. Okay, addition of oxygen is oxidation, but the removal of oxygen is reduction. Next point you can add the removal of hydrogen. Removal of hydrogen is oxidation, but the addition of hydrogen is reduction, right? So these 3 points, just keep this in your mind. These are very important. That's the basic thing you should know, right? So as I said, oxidation, we are just doing the oxidation of aldehydes and ketones. So we are using the oxidizing agent. So oxidizing agent are those agents which oxidizes the other group, but itself it will reduce. Itself it will reduce, right? So this Ag plus, we are using this Ag, ammonical silver nitrate. Ammonical silver nitrate. So here it will give you a Ag plus. यहाँ पे Ag plus. Okay. So here this Ag plus get reduced. Okay, here the gain of electron will occur. Okay, and it will reduce to a corresponding Ag, corresponding silver. So what will be the product? So this will oxidize. This will get oxidized. RCO minus you can write, and you can also write carboxylic acid. This aldehyde will get converted into a RCOOH plus your Ag. Okay. So here you can see it was Ag plus. When the gain of electron occurs, so it will get converted to Ag. Okay, and this is basically what is this? This is your silver. This is known as silver mirror. Okay, this is silver mirror. So we can say that this reaction is, and this test is known as tolerance test. What is this? This is tolerance test, which is tolerance test. And in tolerance test, we use the tolerance reagents. What is tolerance reagent? Ag, okay, silver ammonical nitrate. Silver ammonical nitrate is the here is the tolerance test, and this reaction and this test is also known as silver mirror test. Silver mirror test. Okay, because you can see this silver mirror यहाँ पे बन रहा है, so that's why this is known as silver mirror test. When you will perform in your lab, so it will be very clear. Okay, so in the test tube, you will observe that, okay, silver color ka mirror, the shiny color texture you will see, okay, and that is nothing but a silver. Okay, so silver is getting basically formed. Silver is formed in this reaction, and this aldehyde is getting oxidized to a corresponding carboxylic acid, right? So that is your tolerance test, and that is also known as your silver mirror test. Next test is Next test is your failing test. Failing test. So in the failing test, we use copper 2 plus ion, right? So this copper 2 plus ion, it will get converted into a corresponding. So this aldehyde in the presence of Cu2 plus, it will get converted into a carboxylic acid, right? Okay, RCOO minus, I'm writing. Okay, and here you can also write RCOOH as the same thing. And here you will get a red colored PPT of your cuprous oxide Cu2O. Okay, so this is known as your failing test. This is known as your failing test. Okay. So there are two types of test in your syllabus: tolerance test and failing test. Okay, so aldehyde, when untreated with the silver ammonical nitrate, so it will reduce the Ag plus to Ag, and a silver mirror is formed on the wall of the test tube, right? So that is your tolerance test, or you can also call it as a silver mirror test. Next test is your failing test, right? So failing test is again a test for the detection. This tolerance test, okay, tolerance test जो होता है, this is silver mirror test, is for the detection of the aldehydic group. Okay, only aldehydic group. The ketone will not give this test. Ketone will not give this test, right? Now here, okay, failing test. We will discuss in details about both the test, failing test as well as the tolerance test. Which type of reagent we use in the failing test. Failing test, mein there are two types of solution: failing solution A, failing solution B. Okay, why we don't uh, mix the failing both the failing solution earlier, right? We just mix the failing solution at the time of the experiment. Okay, we will discuss why we do this, but first, just let's write down. Okay, just quickly write down these notes. Written everyone?
Yes, ma'am.
Aisha and Jibita? Okay, next write down the tolerance test. Tolerance test. Have you performed this test in your lab?
No, ma'am.
Okay. Tolerance test or silver mirror test. Yeah. So first point write down when aldehydes react with silver ammoniacal nitrate Ag NH3 whole twice NO3. That is your silver ammoniacal. Okay, this is NH3 whole twice and NO3 nitrate. Silver ammoniacal nitrate, or you can call it as silver ammoniacal ammonium nitrate. So it reduces Ag plus to Ag and a silver mirror is formed. Silver mirror is formed. So when you will perform this experiment in your lab, so it is quite interesting experiment. You will notice, you will analyze the formation of a silver mirror on the wall of the test, right? When you take the aldehyde group, okay, and when you react this with the silver ammoniacal nitrate. So this experiment is quite expensive because here you are using the silver ammoniacal nitrate, right? So this is quite expensive. So in most of the classes, they will not perform this test. Okay, they will not give the students to perform this test. Okay, so basically, the teacher will show you the experiment by their self, and they will not allow the students to perform this experiment. Okay, by yourself. So this Ag plus to Ag and a silver mirror is formed on the wall. Okay, so when you see the silver mirror being formed on the wall, so the test confirms that the aldehyde group is present. Okay, so basically this test is for the distinction between detection of aldehyde group, where the aldehyde group CHO group is present in your compound or not. If you have unknown compound, okay, so you have to basically just distinct between the aldehyde or a ketone, so you can use this test, tolerance test, because ketones will not give this test. Why? Because here you are using the mild oxidizing agent, right? And ketones does not oxidize easily, right? You have to treat a ketone with a strongest oxidizing agent, right? So in some drastic conditions, the ketone will undergo oxidation, okay, otherwise not. It's not very easy to oxidize the ketone. Okay, so write down this one, wall of the test tube. So this test is used for used for detection of aldehyde group. Next point, it is not given by ketones. And yeah, both the aromatic and aliphatic aldehydes can give this test. Okay, both aromatic and aliphatic aldehydes give this test. Okay, and what is tolerance reagent? You can write down tolerance reagent is AgNO3, you can take the Ag silver nitrate plus ammonium chloride, ammonium hydroxide. Okay, you can take this combination also. AgNO3 plus NH4OH. So basically at last it will give you this product. It will give you a silver ammonical nitrate. So when you add silver nitrite, okay, silver nitrate with ammonium hydroxide, NH4OH, so you will get this product. Okay, so you can use this, or you can directly use this Ag. You can write on the arrow like Ag, NH3 whole twice, and NO3, silver ammonical nitrate. Okay, and you can also show it like this because this will get converted when you add AgNO3 plus NH4OH. So it will give you AgNH3 whole twice पे plus charge आ जाएगा. Okay, and on the OH minus, this OH minus will get the negative charge. So when on dissociated in water, okay, when you Ag NH3 whole thrice, NH3 whole twice basically, it will get the positive charge. Okay, this is the cation and OH minus is the anion. It will give the negative charge. So when you are just writing the tolerance test, when you are writing the reaction of the tolerance test, so you can use either this or this or this. Okay, so both are the same thing. Next is your Fehling test. First write it down and update me. Okay, is it clear, Aisha, Jupiter, Muniba?
Yes, ma'am.
Aisha, is it clear, बच्चे? Okay, write down. Hmm. The the other name of tolerance test is silver mirror test. Okay, let's move forward. Second test is your Fehling test. Okay, so let's discuss it in details. So what is Fehling test, right? Now see, Fehling test is again for the aldehydes, carboxylic acid, carboxyl group, okay, carbonyl group. So what is Fehling test? So Fehling test, basically let's discuss the Fehling test. So Fehling test may we use two solution, right? So Fehling test is for the for basically a aldehydic group, right? Aldehydic group, and here basically we use two types of solution. Fehling solution is made by Fehling solution क्या होता है? Fehling solution is a combination of two solution. Fehling A, Fehling, Fehling solution A and Fehling solution B. If you have visited your lab, so you must have noticed that there are two types of Fehling solution. One is a Fehling solution A, and one is a basically one is blue color, okay, dark blue color solution, okay, and the second one you will see that it's a colorless solution, right? So these are two Fehling A and Fehling B solution. Fehling A and Fehling B. Fehling solution B. Right. So Fehling solution A जो होता है, this is the aqueous solution of copper sulfate. Okay, this is the aqueous solution of copper solution, so copper sulfate. So basically, it is CuSO4 pentahydrate, copper sulfate pentahydrate dot 5H2. Right. So Fehling solution is solution A is the aqueous solution of copper sulfate. Okay, when you add copper sulfate in a water, so you will get copper sulfate pentahydrate. So that is the Fehling solution A, okay, which is a blue color solution. Now this second one, the Fehling solution B. Fehling solution B, it's an aqueous solution of potassium sodium tartrate. What is this? It is an aqueous solution of sodium potassium tartrate. So failing solution B, and it's a deep blue color. It's a deep blue color, right? And this solution B is a sodium potassium tartrate, okay, which is also known as Rochelle salt. Rochelle, Rochelle salt is also known as Rochelle salt. Okay, now let's see the structure. So structure of the sodium potassium tartrate is this one. Here, one side COO minus Na plus, and on the one side there is COO minus and K plus, right? So that's why it is known as sodium, okay, and potassium tartrate. So that's the structure, and it is known as Rochelle salts. So this is Fehling solution A, and this is Fehling solution B. Now, how it works? So basically, when you perform the Fehling test, you have to add these two solutions, Fehling solution A plus Fehling solution B. So when you combine these two, okay, and plus you have to add the basic like base NaOH, sodium hydroxide. So when you add these three, so you will get a CuO, copper oxide. You will get a copper oxide, and this copper oxide is treated with the aldehydic group that act with the aldehydic group, and it will oxidize the aldehydic group to a corresponding carboxylic acid plus cuprous oxide, which gives a reddish color PPT. So that confirms the test. Okay, so failing solutions. So always remember why these two are just we can't use them together, right? Basically, we don't. You must be noticed that in your lab they are basically the lab mates basically they keep these solutions separate, failing solution A and failing solution B. Okay, so you must use them together just before performing the test, right? When you have to perform this test, failing test, so before the test, before performing the test, you have to combine these two. आपको जितना amount लेना है, just 5 ml failing solution A, 5 ml failing solution A, B, just combine them together, right? And you can just use this in a test. Okay, failing solution, failing. So that's when you combine these two and when you add the NaOH, sodium hydroxide. So here the reaction will give you a copper oxide. And that copper oxide will be treated, okay, in a further reaction, aldehydic group or the ketonic group, and it will give you a reddish color PPT which confirms the test. If the reddish color PPT will come, then it confirms, then the positive test, then the Fehling test is positive for that given compound, okay, aldehyde or ketones. And just remember that I'm not going to write down in your notes. So these are stored separately, right? These are always stored separately because the copper 2 complex जो होता है, this copper 2 complex formed by their combination. Okay, they form by when you add the Fehling A plus B. So from here, the copper oxide will be formed, right? And copper is two complex. Basically, copper जो होता है ये two state में होता है, right? Plus two oxidation state में होता है, and it is not stable, right? This combination will give you a copper two complex which is not stable. Okay, and it would quickly break down in the alkaline solution if stored together. So that's why we don't them combine them together, right? So before, when you have to perform the test, then only you have to combine these two, Fehling solution A plus B. Okay, so that's why they are kept separately, Fehling solution A and B. Let's see the reaction. Let's see the reaction. Then it will be very clear for you. Suppose, okay, so copper sulfate pentahydrate is your Fehling solution A, right? So basically, it gives you a blue color due to the presence of copper ion. ये किस कलर का होता है? Deep blue color. Why? Due to the presence of copper ion. And the sodium potassium tartrate जो होता है, this Rochelle salt, right? So it is a colorless basically. It is a colorless, right? So Fehling solution B is colorless and Fehling solution A is deep blue color, right? Due to the presence of copper ion. Now, how you will combine these two? Spelling solution A, copper sulfate pentahydrate, right? So when you basically Fehling solution A plus B, so we just take this for Fehling solution A, okay? CuSO4, let's see the reaction first, how you will prepare. So we have to dissolve this copper sulfate pentahydrate in distilled water, right? And we have to add a few drops of dilute sulfuric acid. What you're supposed to do? Copper sulfate plus a few drops of sulfuric acid आप डाल सकते हो, right? And basically, just a second. Okay, and you can do this in a basic condition also. So reaction, write down reaction. When you take this CuSO4, okay, CuSO4 or pentahydrate basically it is, plus 2 NaOH, sodium hydroxide. So it will give you a CuOH whole twice plus sodium sulfate, Na2SO4. That is the reaction for the Fehling solution A. Fehling solution A को first में क्या करते हो आप? You just dissolve it in a basic condition basically, right? Few drops of sodium hydroxide आपको डालना होता है. Sorry for the convenience. I have just told that dilute sulfuric acid. Dilute sulfuric acid नहीं डालते हम. We just add the sodium hydroxide, right? So it will get converted into a copper CuOH whole twice plus Na2SO4, right? So basically the copper ions in this solution give it a blue color. Now let's see the solution B, Fehling solution B. So when you take the reaction, when you see this, when you take this, so what happens? This is your, okay. So when you add, this is your copper sulfate. So copper sulfate, your CuOH whole twice plus your this one. Okay, you will be confused in that. Don't write this reaction. Let's write on the final reaction. Okay, because they are just stored separately and you have to combine them. Okay, so final reaction क्या होता है? When you take this copper sulfate pentahydrate, CuSO4.5H2O, right? Plus, you just add, as I told you, what you are supposed to do. You will take the Rochelle salt plus your deep blue color solution, which is Fehling solution A. And when you add sodium hydroxide in a basic condition, you will perform this. So copper sulfate pentahydrate plus your sodium hydroxide NaOH plus your potassium sodium tartrate. Potassium sodium tartrate. Right. So I'm just writing this COO minus Na plus and here it is COO minus K plus. So this is sodium potassium tartrate. So when you treat these, so you will get a Fehling solution, right? You will get a Fehling solution. And it's a complex, I'm not writing the structure of this, it's a complex structure. Fehling solution आपको मिलता है, right? And basically, Fehling solution has copper to iron, copper to iron, and that copper to iron will just attack the carbonyl compound, your aldehyde compound, and it will oxidize that aldehyde compound to a carboxylic acid, right? So what you're supposed to do if you perform this test in your lab, okay, if you got the chance to perform this. So you will get two types of solution. Valine solution A, which is deep blue color, and what is the formula? Copper sulfate pentahydrate. Valine solution B, which is sodium potassium tartrate, which is also known as Rochelle salt, and this is colorless. Now, आपको क्या करना है? When you mix the Fehling solution A plus Fehling solution B, suppose you just take the 5 ml, 5 ml, okay, and when you add like 2 to 3 drops of sodium hydroxide, so you will get a Fehling solution. You will get a Fehling solution. And this Fehling solution basically it will have the basically यहाँ पे redox reaction होंगे. Here the reaction will occur and the Cu2 plus ion. Okay, the Cu2 plus ion which is here, it will get reduced to a cuprous oxide, Cu2O. Okay, which forms a reddish brown color PPT. When you treat this with the aldehydic group, suppose we just take the, sorry, suppose this is a Fehling solution, it will give you a Fehling solution, final Fehling solution. And this Fehling solution basically has a copper oxide ion. This copper oxide basically उस complex मिलेगा आपको. In that compound complex, you will have a Cu2 plus ion. Cu. So when you take the aldehydic group, RCH group, and when you treat this with a Fehling solution contains CuO group. CuO group. Now, sorry, what happens? So it will oxidize. So this aldehydic group will oxidize to corresponding aldehyde, carboxylic acid, RCOOH. Okay, or you can also write RCOO minus. Okay, as a anion के form में भी आप लिख सकते हो. Plus, it will form a undissolved substance, okay, which is known as cuprous oxide. Cuprous oxide. So you will notice that the undissolved reddish color PPT, okay, is settled in the bottom, okay, at the bottom. So this is red color PPT. So which confirms the test. It shows that it demonstrates that the aldehydic group is present in your compound. It confirms the aldehydic group, right? So this test is used for the detection of aldehydic group, okay, like your benzaldehyde, your aromatic aldehydes, etc. But only, not just a second. One more thing. This is important. Just write down. So here, benzaldehyde. Okay. So benzaldehyde or any other aromatic aldehyde will not give this Fehling test. They don't give Fehling test. They won't give Fehling test. So this test you can perform to distinct between the aromatic aldehyde or the aliphatic aldehyde. Okay, if they will give you two types of like statement type of question, they will give you just like a benzaldehyde or any just like your propanol. Okay, benzaldehyde, how the benzaldehyde is different from the propanol. How you can distinguish between the benzaldehyde or propanol. Okay, so propanol is your aliphatic aldehyde and the benzaldehyde is your aromatic aldehyde, right? So you can distinguish between these two aliphatic or aromatic aldehyde by using this test, Fehling test, right? Because aromatic aldehyde will not give this test, but your aliphatic aldehyde will give this test. You will get a red color PPT at the last. So it will give a positive test for the aliphatic aldehyde, but it will give the negative test for the aromatic aldehyde. Is it clear? This point is clear?
Yes, ma'am.
Any questions, Jibita, Muniba?
No, ma'am.
Okay, so just ask your teacher. Okay, ask your chemistry teacher in your school to perform this test. Okay, so it will be very interesting for you. And when you perform by yourself, so it will be very clear. Okay, next up, only aliphatic aldehydes gives Pelling test. Okay, again the ketones will not. Ketones don't give Pelling test. So just remember ketones don't give the Pelling test and tolerance test, right? So again, you can use this test to distinguish between aldehyde and ketone also. If the aldehyde is aliphatic, if the aldehyde is aliphatic, okay, so you can distinguish between the aliphatic aldehydes or ketones by using this test. Third test. Now, first you can write it down. Just note it down from here. Spelling test. Mm. Okay, so the next test is your haloform test. Haloform reaction. So in haloform reaction, we will basically discuss the iodoform reaction, right? So haloform reaction, the general reaction is haloform. Haloform. So haloform is CHX3. This compound is known as haloform. When the X3 halogen group is attached to this carbon, so this is known as haloform, just like a chloroform, CHCl3. Okay, just like your iodoform, CHI3, right? So these are known as haloform, right? CHX3. So haloform reaction are those reaction in which the haloform is being formed. Okay, the reaction in which the haloform is being formed. Suppose we just take the carbonyl compound CH3CH. Okay, now, so this haloform reaction, okay, the carbonyl aldehyde group as well as the ketone group can give this test, this haloform test, okay, or haloform reaction. The main thing is for the haloform reaction, the condition is the presence of this group. CH3CO group should be present. CH3CO group should be present. And here there will be any group. This is must. CH3CO group means acid group is present. Acid group present hona chahiye, then only that reaction, this compound will show the iodoform test or haloform test. Right. So this is the main thing. This group is important. CH3CO group, acid group is present. Acid group should be present. And here, in the place of H, it could be either your alkyl group, any alkyl group bhi ho sakta hai, when you replace hydrogen by any alkyl group. And in the place of hydrogen, it could be your aromatic. Okay, you can attach the benzene group also. So it will, the main thing is the presence of this group, CH3CO group will be attached. Now, what is the reagent we use in this haloform reaction? So we use the sodium hydroxide plus your X2, okay, X2. Or you can directly use Na when you react sodium hydroxide with X2, okay, your halogen. So it will give you a NaOX, NaOX, right? So directly you can write down NaOX, okay, NaOI, NaOCl, etc., NaOBr, etc., or you can use this, okay, sodium hydroxide plus X2. So when this group CH3COH, okay, this group is treated with sodium hydroxide plus your halogen. So what happens? What happens using this group? So basically, this CHO, this CHO group is getting oxidized to get oxidized to CHO minus. Okay, and you can also write hydrogen over there. Okay, so basically it will form HCOOH, HCOOH, right? Formic acid. It will form formic acid. So this aldehyde group CHO, this group will oxidize to a corresponding carboxylic acid, and this group CH3 group ये क्या form करेगा? Iodoform. Okay, iodoform or haloform you can say. So haloform, you know very well what is haloform, CH, and to the carbon 3x, 3 halogen group should be attached. So by using this carbon, one carbon, you will form CH and X3, right? It will be X3 plus this. Okay, so this aldehyde group, or whether it should be ketonic group, यहाँ पे ketone group भी हो सकता है, right? Any CH3. Suppose if I attach CH3, okay, on the place of hydrogen, so it could be your CO, okay, CH3 over here and OH over here. So it will form this again. The ketone will be well converted into a carboxylic acid over here, right? Or here again you can write R or aromatic system. Hmm. So this is your haloform reaction. If I take the iodoform, so in the if I'm just saying that it is iodoform reaction, so here instead of X2, I will write I2, iodine. Okay, suppose CH3, again the same group, CH3COH. In the place of H, you can write hydrogen, your alkyl group, and you can also write aromatic system. Okay, suppose this is CH3CO, and in the place of hydrogen, if you attach CH3. So ketone can also give this test. Only the condition is that CH3CO group should be there. If CH3CO group is not there, then this test will not be proceed, right? And here in the place of hydrogen, it could be your CO and aromatic system, means acetophenone. What is this? This is your acetophenone. This is your acetophenone. So acetophenone as well as ketone as well as your aldehyde can also give the test, but the condition is this group. This group should be present. CH3CO group, acid group should be present. That is the condition. Next reaction, sodium hydroxide plus I2. Okay, if you are using the I2, so it will give you a NaOI. NaOI. And in this case, instead of X, you will write CHI3. And what is this? This is your iodoform. This is known as iodoform, which is yellow color PPT. When you treat the aldehyde group or ketonic group, which is having CH3CO group in it. So in the presence of sodium hydroxide plus I2, so it will form a iodoform. Okay, it will form a yellow color PPT, and yellow color PPT is nothing, it's just a iodoform. Okay, so CHI3. So if iodoform is being formed, means yellow color PPT अगर आपको मिल रहा है इस reaction में, so the test is being confirmed that it means that CH3CO group is present. Okay, and it can be either your ketone, okay, or your aldehyde. The aldehydic or ketone, which is having CH3CO group, will give this test. Plus, what will be the other product? Okay, so this group, this aldehyde is CHO group. So it will be oxidized to COH and oxygen will be added over here, right? Or we can write this. That is the product. Okay, is it clear? The haloform reaction.
Yes, ma'am.
And this reaction is known as iodoform. Iodoform reaction. Suppose if I give you conclusion, you can write down. In the conclusion part, we have done three reactions, three tests basically. First, we have done the tolerance test. Second test was the Fehling test. Fehling test. And the third test is your iodoform test. Now, if we take aliphatic aldehyde, aromatic aldehyde, or ketones, okay. So the tolerance test, which group or which compound will give the positive tolerance test. So this aliphatic, this is for the aliphatic or aromatic aldehyde. So aliphatic or any your benzaldehyde or any aromatic aldehydes can give this test, positive test, right? So yes, the tolerance test is given by the aliphatic aldehyde. Yes. Tolerance test is given by the aromatic aldehyde. Yes. Okay, but ketones does not give this test. Fehling test. Yes, Jupiter, tell me. Will the Fehling test is given by the aliphatic aldehyde? Yes or no? Yes, right. So Fehling test is given by the only aliphatic aldehyde, not by the aromatic one, not by the ketone, right? So you can distinguish between the aliphatic or aromatic aldehyde by using Fehling test, okay, or aliphatic aldehyde or ketones by using this test. Next, for the iodoform test. Okay, so iodoform test can be given by both aldehydic or ketone, but the condition is for the presence of this group. CH3CO group should be present. And here, any group should be attached hydrogen, your alkyl group, or it could be a benzene ring, right? So this group should be there. If this group is there in your compound, then the iodoform test will be positive. Clear to everyone?
Yes, ma'am.
Okay, so I will give you some questions based on that base test. So please make sure to submit your homework before the next class. Okay. And yeah, Muniba, yeah, just do correction in your note in the failing test. Right, in the failing test in your notes, it's written as copper sulfate plus NaOH. But NaOH we just take at the last when we add these two failing solution A plus failing solution B. Right. So basically, failing solution A is your copper sulfate pentahydrate, which is deep blue color. Okay, just make correction in your notes, which I have shared earlier. Okay, any doubt from today's class? Jibita, Maniba?
No,